Hey guys, we're finishing up chapter 1 here for natural selection. And remember, the phenomenon we're looking at is that population of newts in Oregon. So on your big idea page, you should have the question, why do populations change over time? That's a general question about all populations. So we're looking at that general question, and then we're hyper focusing it down to our phenomenon of the newts. And throughout this chapter, we've done a lot of simulations with species that aren't real, the thorny palm, the australopes, and the carnothorns. So we have the question for chapter 1, what can cause a change in a population? And the answer to that question is here in these key concepts. A population can be described by the traits present and the number of individuals that they have. The traits that exist in a population determine which traits can become more common over many generations. So that's one of the key factors into what's causing change. Over many generations, individuals with adaptive traits become more common in populations, while individuals with non-adaptive traits become less common. Remember, adaptive traits are traits that increase the chance of survival, like camouflage or poison level. And then non-adaptive traits would be traits that don't increase chance of survival. This could be like a hot pink bunny running through a field of brown grass, right? That's probably going to get picked up pretty quick by a hawk or a coyote or a dog or anything because it's easy to see. Whether or not a trait is adaptive depends on the environment, which means down here, the one in green, which should be in green on yours as well, because it's a cross-cutting concept of cause and effect. Biologists analyze data about populations and the environment. That's the cause. To explain changes in the distribution of traits of the population, that's the effect. If you understand and can explain those 5 main ideas, then you're doing pretty good for chapter 1. Okay, so make sure that gets in there on your slide.